Hi, welcome back. This is Professor Ridge, and today's lesson on section 7.7, the distance and midpoint formulas and other applications. So first we'll start off with Pythagorean Theorem, and basically if we have a right triangle, meaning one of the angles is 90 degrees, the legs we call A and B, so that's a leg, and then the hypotenuse, that's C. We know that if you square the legs, the sum of the square of the legs is equal to the square of the hypotenuse. That's a pretty famous theorem. And also we have the principle of square roots, which we're going to cover a little more in next chapter. Okay, so let's try exercise 8. It says find the missing side. So if A is 8, B is 10, we're going to find C. So using Pythagorean Theorem, A squared plus B squared equals C squared. So we're going to do 8 plus 10, so that's 64 plus 100. Oh, and then it says to find your answer to 3 decimal places if appropriate, approximate it. Okay, so we use the square root principle. So C is equal to plus or minus the square root of 164. Now, since this is a geometry problem, right, we don't consider the negative one. We just throw that one out because it doesn't make sense to have a negative side. And then take the square root of 164. So the exact answer is square root of 164, but it's approximately equal to 12.0806. So they want both answers. All right, let's try number 12. So let's see, A is, now it doesn't matter, A and B they're the legs. It doesn't matter which one you call A and which one B, just as long as they're on that right angle. That's what the legs are. C is opposite the right angle, and that's the hypotenuse. Okay, so for 12, A is 7, B we don't know, C is 25, and we want to find B. So again, Pythagorean theorems, A squared plus B squared equals C squared. Plug in the numbers you know. A is 7, B we don't know, C is 25, so we get 49 plus B squared is 625. We're going to subtract 49 from both sides. So B squared is 576. Square root both sides. And again, the negative one, since this is a geometry problem, we don't want a negative side, so I'm not going to worry about writing the negative one. And then that actually is 24, I believe. Yep. Exactly, so I don't need to approximate it. Alright, number 20. How long is a guide wire if it reaches from the top of a 15-foot pole to a point on the ground 10 feet from the pole? Okay, so we're going to make an assumption that the ground is level and this pole was installed plumb to the ground, meaning it's a 90-degree angle. Of course, this is not to scale because we said this was 15 feet, 10 feet. We want to know X. How long is that guide wire? Okay, so we're going to use Pythagorean Theorem. A squared plus B squared equals C squared. And it doesn't matter what you call the sides. The C squared, the one that's all by itself, is opposite that right angle. So that's going to go all by itself. So we're going to get 15 squared plus 10 squared for A and B. So that'd be 225 plus 100. That's 325. And again, we're going to square root both sides, so we get square root of 325. And it's plus minus, but again, since it's a real-life application problem where we don't want to have a negative for the wire, that wouldn't make sense, so we throw that one out. Square root of 325 is about 18.0. How many places do we want? It doesn't say, so go out 3 places. That's probably good enough. 18.028 feet. So it's a little longer than 18 feet. Okay, so we have 2 special right triangles that we have to memorize. There's the 30, 60, 90. And a 30, 60, 90 triangle comes from, if we start out with a equilateral triangle. So this is 60, 60, and the top would be 60. And what's unique about all those sides is they're equal. So if I let this be, we'll call this 2x, 2x, and then if I drop the altitude from the vertex at the top there, that's going to be a right angle, and that splits that 60-degree angle into 2 30s. So see, that's going to give us x, x. So if we just look at the 30, 60, 90 triangle, which is half of an equilateral triangle, this is going to be x, this is going to, the hypotenuse would be 2x. And using Pythagorean Theorem, if I want to figure out what b is, so we're going to get, here we'll call this b. So x is where a is. So it'll be x squared plus b squared equals c squared. Remember, that's opposite the right angle. So that's the 2x squared. And if I want to solve it for b, you get 4x squared. Subtract x squared from both sides. So that's 3x squared. Square root both sides. Throw the negative 1 away. So we get the square root of 3x. Or I'm going to move the x to the front. Right? Right, so we got x squared. That comes out x square root of 3. That's where that came from. Okay, so this is going to be, so we memorize this relationship between the sides. We have so now I'm not going to call it b anymore. Alright, so we memorize this. So if I want you to find the sides, instead of having doing Pythagorean Theorem, I just know the relationship between the sides. This is what's called the short leg. It is half the distance of the hypotenuse. And then the long leg is the short leg times square root of 3. So that's why I have, this is x, the hypotenuse is twice whatever x is, and the long leg is whatever the short leg is, x, square root of 3. We just remember that. So if I give you find the missing side, say a is 10, then b is going to be 10 square root of 3, and c, remember, that's going to be twice x, twice the short leg, and x in this case is 10, so it's going to be twice 10, which is 20. Okay, so it's pretty straightforward that way. Alright, the next special right triangle is going to be a 45, 45, 90. And what's special about that one is that two angles on a triangle are equal, the sides opposite those angles are equal. So that means that if this is x, that one's x. So both legs would be x. And then again, using Pythagorean Theorem, x squared, a squared plus b squared equals c squared. We get 2x squared equals c squared. Square root both sides. We throw the negative 1 away. That's going to get us x square root of 2. X square root of 2. Right, so that's the relationship between the sides of 45, 45, 90. Okay, let's try a few examples. Alright, so we see this 45, 45, 90. So you just got to remember the relationship. The legs are equal to each other. So if this one's 14, B is going to be, I guess I should have left it with A, B, and C. So I can use X or A, it doesn't matter. Right, on a 45, 45, 90, this is A, B is equal to A, and C is equal to A root 2. So I used A's instead of X's, just make it more familiar that way. So the missing side here would be, this would be 14. B is equal to A is 14. So B is 14, and C is going to be A root 2, which will equal to 14 square root of 2. Let's try 36. So we got a triangle like this. And this is a 30, 60, 90 triangle. You got a 7 here. So you got to remember a 30, 60, 90 triangle. Again, I'll use A's instead of X's. So this would be A, B, C. So A is going to be A, or X. B is going to be A square root of 3. C is going to be twice A. Okay, so we got to kind of, in our head, imagine flipping this circle around to match the, or base 30, 60, 90 triangle. So let's see, the short leg is A. The hypotenuse is C. Hypotenuse is opposite the right angle. Okay, and then the long leg, that's B. Now from memorizing the special right triangle, we know that B is equal to A square root of 3. So what I do is, from the picture, B is, we're told, is 7. So now I'm just going to solve this for A. So I'm going to divide both sides by square root of 3. And then I'm going to simplify 7 square root of 3. Sorry, 7 over square root of 3. I got to rationalize the numerator. So scratch work. 7 square root of 3 over 3 is A. I'll just leave it here. And now I got to figure out C. C is equal to twice A, and we just worked out A is 7 square root of 3 over 3. So C is 14 square root of 3 over 3. And there you go. So those are the two missing sides. So you just have to memorize these relationships. So for either a 30, 60, 90 triangle or 45, 45, 90 triangle, if you're given one side, you can figure out all three. So you can figure out the missing two. Okay. Okay, so the distance formula is actually just the Pythagorean theorem in disguise, because if you're on an x and y axis, like this for instance, and we have this point x1, y1, and this point x2, y2, sub 2, what we can do is we can draw in this right triangle, and it turns out that A is just going to be the difference between x sub 1 and x sub 2. So we're going to subtract those. X sub 2 minus x sub 1. And B, I guess I can write it here. A equals x sub 2 minus x sub 1. And B is going to be equal to y sub 2 minus y sub 1. So if I use Pythagorean theorem, I know that C, which is my distance, between the 2 points, so if I wanted to find that C, we use a squared plus b squared equals c squared. And we know A, we're going to subtract the x coordinates, square it, subtract the y coordinates, square it, and then we're going to square root both sides. So C equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So it's really the Pythagorean theorem in disguise. So we come up with that theorem. So the distance, here I'll just write it. Alright, so the distance is, again, just the Pythagorean theorem, just looks a little different. Alright, let's try a couple of those. Next page. Okay, so again, we're just going to use the formula. B equals square root of, we're going to subtract the x coordinates, plus subtract the y coordinates. We're going to square each of those, and then add them together and square root it. Okay, so the distance is, so remember, this is x sub 1, y sub 1, x sub 2, y sub 2. So I'm going to subtract the x coordinates, 6 minus 0 squared, subtract the y's, 0 minus 8 squared. So that'd be 6 squared plus negative 8 squared, which is 36 plus 64, which is square root of 100, so that's 10. So the distance is 10 between those 2 points, 10 units. Now let's try another one. How about 521 and negative 3, 1. So we're going to subtract the x coordinates, square it, plus subtract the y coordinates, square it, add them together, and then square root it. So let's see, we're going to get negative 3 minus 5 squared plus 1 minus 21 squared, which that gives us negative 8 squared plus negative 20 squared, 64 plus 400, 464, and it's not asking us. Okay, so that's the answer. We could simplify it, but they're saying just approximate it to 3 decimal places, so we don't have to worry about writing the simplified form. Just punch it in your calculator, round it to the third decimal place. That's what they're asking for. Alright, now the next thing, or the last thing for this section, is midpoint formula. Between 2 points. So the midpoint of the line segment with endpoints x sub 1, y sub 1, and x sub 2, y sub 2. So basically there's just any 2 points. The way you find the midpoint between them, you can think of it as like the average. You add the x coordinates, divide by 2, add the y coordinates, divide by 2. And as simple as that. Okay, so that's a big formula. Let's try one. Find the midpoint. Between the 2 points. So let's do 66. We got 1, 4, and 9, negative 6. So the midpoint would be equal to x sub 1 plus x sub 2 over 2, y sub 1. So again, you add the y coordinates, divide by 2. So we're going to add the x coordinates, divide by 2. Add the y coordinates, divide by 2. And we get 10 over 2, negative 2 over 2. So we get 5, negative 1. Okay, simple as that. Alright, so that completes the lesson for 7.7. Go to my math lab, complete your exercises there, and I'll see you next time.